Hey there, welcome back. In this video, we will try understanding how we can solve a B-tree deletion operation problem. I believe you have already watched how you can perform B-tree deletion operation and what different cases that are possible in a B-tree deletion operation, like when we apply borrow operation and when we apply merge operation, and what is level imbalance situation in B-tree deletion operation. If you have not watched that video, do watch that video first to understand this problem solution very clearly, because we are going to make use of the same situations and cases and different operations in this problem solving, and it is really important to understand them first. So now let us dive into the solution for this problem. So if the question is asked for you in any exam or interview like this, so first we have to check the order of the tree. So the order of the tree that it is given to us is 4. So now you should quickly calculate the C max, which is the maximum number of child nodes, so which is very same as m, which is 4, and you should calculate C minimum, so which is 2, and you should calculate importantly K max and K minimum. Now this is really important for the deletion operation or insertion operation. So K max for this order 4 is calculated like this, so which is 4 minus 1, which is 3, and K minimum is just subtracting the C minimum, so which is 2 minus 1, or it is like m by 2 minus 1. That is the formula that we use. All right, so in that case it is 2 minus 1, which we will end up with 1. So if you do not know how I came up with these numbers, I already explained all this in B-tree introduction video, and I will share that video link in the description. Do watch that video first so understand how these numbers I came up with, and it is really important, and because these are all the important properties of B-tree to be satisfied after we perform the deletion operation. And the other important rule is that all leaf nodes must be in same level. Right? All leaf nodes must be in same level. Now these are all the important properties of B-tree which must be satisfied after deleting a node. Now we will see how we can go with this deletion problem solution. First, we have been asked to delete 1. So now we will try deleting 1. Okay, so first we should see whether 1 is present in the tree or not. So we can see that 1 is present in the tree, and this falls in the first case how I explained in the previous video. So that is, we have more than the required number of keys within the deleting node. So here this is the deleting node, and what is the minimum number of keys that there should be? 1. So here we have more than the required number of keys, so we can delete it directly. We don't have to worry about anything. So now let me just delete that particular key. So the tree is going to change into something like this. Now if you see, after we delete value 1 from the tree, so the tree is going to look like this. Now we should validate whether it is following all the rules of B tree or not. And just keep in mind, so the only two properties which will be affected in deletion operation in B tree is K minimum and K maximum, and level imbalance problem. And if these three properties are satisfied, then we can say that the B tree is satisfying all the properties. Now if you see the K minimum property is 1 and K maximum property is 3, and level imbalance should not be there. So now if you see, after we delete a node from this particular, after we delete a key from this node, we still have the minimum number of key property satisfied. So here we have still more than the required number of keys. So now we can simply go with the next number deletion. So what is the next number to be deleted? So that is 2. So now we will delete 2. So first we should see whether 2 is present in the tree or not. So we can see that 2 is present at this particular position. Now I can go ahead and delete it. So first you delete it, and then we can go ahead and see if they are following the properties of B tree or not. If they are not satisfying the properties of B tree, that is when we have to see which particular operation should be applied in that case. So now let me delete that node first, and let me just write how the tree is going to get changed into. So if you see now, after we delete node 2 or key 2 from the tree, so the tree is looking like this. So now we have to validate the K minimum and K maximum property, and also level imbalance property. So after we delete 2 from this particular node, we still have the minimum number of keys. So now we don't have to worry about any other operations to be performed. We can simply go with the next key deletion operation. So what is the next key to be deleted? So the next key that should be deleted is 13. Right. So first we will search whether 13 is present in the tree or not. So we can see that 13 is present at this particular position, so which is this position. So since it is available in the tree, and also it is a leaf node, so I can go ahead and completely delete it straight. So I can see that 13 is present at this position and 13 is a leaf node, so I can delete it directly. So now let me write the complete. Now let me write the updated tree after we delete 13. Now if you see the updated tree after we delete 13 from the tree is this. So we had extra keys in this node and that is why we have deleted directly, and we don't have to worry about performing any other operations like borrow operation or merge operation. And it is satisfying the property of k minimum also. So then we can go with the next number to be deleted. So the next number that we should delete is 8. Right, and first we will see whether 8 is present in the tree or not. So we can see that 8 is present at this position and 8 is a leaf node, so I can delete it directly. Now let me delete that node and write the updated tree. Now if you see, after we delete 8 from the tree is updated like this, and after we delete 8 we don't have the minimum number of keys, and now we should see if we can borrow a key from the sibling. Now who is the sibling for this node? So the sibling for this node is 11. But even in the sibling node, we don't have the extra keys. Like how we seen in the previous video, we have different situations, and this situation comes under this case, where we don't have minimum extra keys in the deleting node and we don't have extra keys in the sibling also. And in that case, what did we do? We tried merging the parent and the sibling node. So in this case, the sibling node is 11 and the parent is 9. So what did we do? We have to merge this 9 and 11 and make that as a new child node for 15. And this is how this merge operation is going to work. So this merge operation should be made use when we don't have extra keys in the node and also we don't have extra keys in the sibling node. In that case, we are going to perform merge operation. Now let me write the updated tree for you. So after the tree is updated, so the tree is looking something like this. And do understand why we perform merge operation here. I have already explained why we should perform merge operation in the previous video. Do watch that video to understand this step better. All right. And now we should be validating the k minimum property. And here if you see, all the nodes are having at least one key, which has to be the rule for the given m equals to 4. Now since it is satisfying all these properties, now we don't have to worry about anything, and then we can delete the next value. So the next value which should be deleted is 6. Sorry. So the next value which should be deleted is 6. Now here if you see, so the 6 is already in the tree, but 6 this time it is not a leaf node, it is a parent node. And not just parent node, it is a root node. So it doesn't matter whether it is a root node or parent node. So root node is also a parent node. And if it is a parent node in binary search tree, what did we do? We tried swapping the internal node or parent node with the in-order successor. If the in-order successor is not present, then we are going to go with the in-order predecessor. So here if you see, for 6 we have a right subtree, and in right subtree the in-order successor for 6 is going to be 9. Why 9? Because in-order successor is what? So in-order successor mean the smallest number in the right subtree. So the smallest number in right subtree. So the smallest number in the right subtree for 6 is 9. So we are going to swap 9 with 6. So let me swap those values first. So here if you see, after we swap 9 with 6 and 6 comes to this position, and as 6 to be deleted, now 6 is a leaf node, so I can go ahead and delete 6 without any trouble, right? But here is the catch. Sometimes we will end up with, after deleting 6 from here, we will not have any key here. So in that case, we have to see either we can borrow from the sibling. So now the sibling of this particular node is this. So we can borrow it from this particular node. And here, since we have extra keys, I can borrow. If in case if there are no extra keys here, then we have to merge this particular values and make that as a new node, and this will be the new parent. We will come across that situation also, but do not worry, we will see how it can be performed. I believe you understood how I performed this 6 deletion. So to delete 6, 6 is a internal node or parent node. I have swapped that with the in order successor, which is 9, and then deleted 6 directly, right? Now all the nodes are satisfying the minimum key property, which is k minimum equals to 1. Then I don't have to worry about anything. So the tree is balanced. Now we will delete the next element, which is 9. deleting 9. So to delete 9, first we should search whether 9 is in the tree or not. So 9 is in the tree and it is not a leaf node, it is a root node. And since it is a root node, again I have to swap that with the in-order successor. Now who is the in-order successor of 9? Which is 11. So now I have to swap it and delete it directly. Now let me complete that step for you. So 11 is going to go up. So here if you see, after I swap 11 with 9 and now 9 comes to this position, and after 9 got into this position, I can go ahead and delete it directly because 9 is a leaf node now, right? So this is how the deletion operation works. But do we have all the properties of B tree satisfied? No. So what is the K minimum property for this particular tree for the problem given, which is 1. But here if you see, here we don't have the minimum required number of keys. So what should we do in this case? We should see if there is a possibility for us to borrow from the sibling node of this. So who is the sibling of this? So this particular node. So here we can see that there are extra keys which can be borrowed. So since it is a right sibling, we have to borrow something called in-order successor again. So the in-order successor in this particular node is 24. But 24 cannot be placed directly here. We have to swap it or borrow it through the parent. So this 24 is going to go up and 15 is going to come down. So this is how the borrow operation works. And let me complete that tree for you. So after borrowing it from the right sibling who is having a extra key, so the tree was updated into like this. Now if you see, the K minimum properties are satisfied. So that means all the nodes are having at least one key and which is satisfying the properties of B tree. So I believe you understood how this deletion operation is performed. Now we will see how we can delete the next node. So the next element that we should be deleting is 5. So let us delete 5 now. Okay. So 5 is present at this particular position and it is a leaf node, so I don't have to swap it with any of the child nodes. I can delete it directly. So let me write the tree for you. So the next element that we should be deleting is 5, and we should check whether 5 is present in the tree or not. So 5 is present at this position and it is a leaf node, so we can delete it directly. But before we delete it, do we have the required minimum number of keys? So here if you see, we don't have extra key in the deleting node and we don't have extra key in the sibling also. So in this case, what did we do? We have to merge the parents. So we have to merge 4 and 0 and make that as a new node. So let me complete that first, and then we will also come across something called level imbalance in this particular situation. So do watch this clearly. All right. So first let me write the updated tree. So now if you see, the updated tree is looking like this, but here we have a problem called level imbalance. So this root node is level 0, this is level 1, and these are level 2. So now if you see, this leaf nodes are in level 2 and this leaf node is in level 1. So which is a level imbalance problem. And what did we do in previous video? So if it is a level imbalance problem, we have to merge the parents of different levels. So we have to merge the parent of level 1 with the parent of level 2. So we have to merge 11 with this particular nodes. So let me complete the tree for you and show you how it looks. So if you see now, the tree is updated into this. So now we have all the leaf nodes in the same level and all the nodes are having at least one key value, which is a property of K minimum for this problem. And now this is a valid B tree. Now let us go ahead and delete the next element. So what is the next element that we should be deleting? So after we delete 5, so the next number that we should delete is 45. Now we will see how we can delete 45 from this tree. First we should search whether 45 is in the tree or not. So 45 is in the tree, but it is not a leaf node, it is a internal node or parent node. So if it is a parent node, we have to swap that with the in-order successor. Now in-order successor of 45 is 63. So I have to swap 45 with 63. Now the tree will be changed into something like this. So now if you see, the tree is updated into something like this after we swap it. Now we can go ahead and delete 45, which should be the deleting node, right? So now we have deleted 45 from the tree, and after deletion, if you see, all the leaf nodes are in the same level, and also we have at least one key in every single node. So now we don't have to worry about any other operations to be performed to balance the tree. So now we will delete next element, so the last element, so which is 100. So let us delete 100 from this tree now. So first 100 is present in the tree or not, we should check, and we see that 100 is present in the tree and it is a leaf node, so I can delete it directly. But before deletion, just see if there are extra keys or not. So for 100, there is no any extra key within the node, and we should see if we can borrow it from the sibling, and the sibling for 100 is what, 30. But in this node also we don't have any extra keys, so it cannot borrow. And what should we do in this case? We should try and merge this into one particular node. And let me show you how the tree changes into after performing merge operation. Now this is how the tree is going to look into. If you see, after we delete 100, so we don't have extra key to borrow, so we merged the parent and the sibling into one node, and this is how the tree looks like. And now if you see, all the nodes are having at least one key value, which is the required property to be satisfied, and all the leaf nodes are in the same level. Now this is how you solve the given problem for a B-tree deletion operations. And if you have to delete 15 in this tree, we can delete it directly because it is a leaf node, and since it is not having extra key, we can either borrow it from the left sibling, or either we can borrow it from the right sibling. So if it is left sibling, then we have to borrow 4 because it is in order predecessor, and if it is right sibling, it has to be in order successor, which is 30. Let me show that to you. Now this is an extra step just for you to understand. Let me just show you the updated tree. After we delete 15, so we can borrow a in order successor or in order predecessor. Now I'm going to go with in order successor, which is 30, or I can also go with in order predecessor, wherein borrowing 4, but you know that borrowing will not work directly, it has to go through the parent. Okay, let me show you how the tree will change into. So now if you see, the tree is looking like this after we borrow a in order predecessor. It can also happen with in order successor. Let me show you that case also. So if it is with in order successor, then it is going to be 30. So let me write the updated tree for you. So it is going to be, so this is how it is going to look like. So if it is in order predecessor, the tree would look something like this. And if it is in order successor, then it is going to look something like this. Right, so these are all the two possible cases, but it is not a rule that you should go with only in order successor every single time. You can also go with in order predecessor or in order successor. So my suggestion is this: so go with in order successor if there are extra keys in the right sibling. So if go with in order predecessor if right sibling is not having extra keys but left sibling is having an extra key, and if both the siblings are having extra keys, you can go with either in order successor or either with in order predecessor, and the choice is left for you. I hope you have understood how the deletion operation works and how you can solve a B-tree deletion problem for the given tree and for the given list of numbers and for the given order M. Alright, so now a very quick question for you. So can you answer how we can delete 30 from here, and what will happen if 30 is deleted from this tree? So just mention that in the comment section so that I'll respond back to your answers. Thank you so much. Have a wonderful day ahead. Thank you.